All right, let's do a practice problem. Assume we have a data for 80 periods. We'll be using moving average of 10 periods to calculate our forecast for period 81 onwards. Once we have forecast for period 81, the demand for period 81 occurs. Once we have a forecast for period 82, the demand for period 82 occurs, and so on. So we're able to calculate the errors by comparing the demands and forecast over period 81 through 100. Okay, this is the same file that I have been using for the slides. It's called oneerrors.template, and I'll post it in Canvas. I'll walk you through this example. All right, let's get started. Let me get rid of this from here, and we're ready to get started. All right, this file has 100 demands, but I hid the 6 through 60 there so that I can show this all in one screen. All right, let me calculate the moving average. Let's start at period 81, right? Just so that you don't forget, let me mark this. Okay, we start at 81. To get the moving average at 81, we do average and look at the last 10 data points starting at 80th through all the way to 71. I got the average, and that's our forecast. It's our point forecast. Error, now the period 81 happens, we see the demand of 52. Right? We see the demand of 52. That means we had predicted 55 and we saw 52. We made an error of 3.8. Right? To get the absolute error, and in this case the absolute and the error is not difference because it's already positive, it's really ABS, absolute value function of this number. That's what we get. Okay. To get the mean squared error, that is really this value squared, right? And to get the absolute value, the mean absolute percentage error, well, we need is a absolute value. Again, we could have done using the second value here and divided by the demand. You can really put this outside actually. It really doesn't make a difference. You put it inside or outside because demand is always positive. You get 7%. Right? Let me drag this all the way for 81 through 100 period. Right? So these are the predictions. If we make it slightly smaller here so that we can see, oh, a little too small here. So these are the predictions. This is the mean deviation. This is the mean absolute deviation. This is the mean squared error, and this is the mean absolute percentage error. Okay. All right. The more important thing here is, can we come up with a average measure here? The average MAD. So this one was even smaller. All right, average MAD. So this is MAD. The average MAD is 8.9. You can do the same for mean squared error. Average mean squared error is 113.51. Mean absolute error is mean absolute percentage error is, let me, so that we can see this slightly better, let me convert this into percentage. About 19.72%. Okay, but the real value of this error method, looking at the error, lies in the fact comparing models. So instead of using 10 data points, what would have happened if I had used moving average of 20? So let me put this here, and instead of 10, let me do 20. Okay, and we'll compare this. We'll do the exact same thing, and we'll comment on what these values really mean. All right, to get the M20, and we're trying to make a prediction again at the 81st period, but this time we're going to use last 20 values. Okay, we're going to use 80 all the way through 61. Okay, we're going to use 80 all the way through 61. We're going to get the mean absolute error again. Instead of 55.8, now we have 55.5 when we're using 20 values. Now the error is minus this 3.5 instead of 3.8. Absolute error is just average. Oh, sorry, not average, absolute equals to ABS absolute value of this mean squared error is just the square of the absolute value, and this is absolute value of this divided by your actual demand expressed in terms of percentage. All right, now we can drag this all the way for next 20 periods, and we can calculate the same kind of statistics that we calculated. The average of mean absolute deviation is average here calculate the mean squared error. Now let me calculate the mean absolute percentage error. Okay, so let me convert this into percentage. And all right, so what do we see here? If you compare MAD, just to compare MAD, the average mean absolute deviation, you're off by about 8.5, 8.9 if you're using MA10. If you're using MA20, you're off by 7.65, right? You're off by meaning what you eventually saw versus what you predicted, right? So this is MAD, mean absolute deviation is usually easy to interpret. MAC, the squared error is 113 versus 92.61. Still, the lower is better, but it's not easy to interpret as just like MAD. The square of the error is the average of the square of the error is 113 versus average of the square error is 92.5. The percentage here is also low. So the idea is you want to model. So in this case, compared to MA10, MA20 is a better model to predict what's going to happen in the future because either of these errors are lower. This is not always the case. There are examples where one MAD might be lower in one and MSC could be lower than other one. It really is possible. It sounds weird, but it is possible. Again, depends. What is the intuition is at MSc you are penalizing the bigger mistakes much heavily. So think about this. You have an error of 1, right, versus error of 2. Error of 2 is only twice as bad as error of 1 in MAD. But in MSc, the error of 2 is 4 times as bad as error of 1. Because the square of 1 is 1, square of 2 is 4. Right? Similar can be said error of 2 and error of 3. Error of 3 is only 1.5 times worse than error of 2. But in MSc, squared error, 2 squared is 4, 3 squared is 9. Right? So it's more than double actually. So which one is better? I don't know. Depending on what your problem is, does it hurt you more if you're off by higher number? Then you want to use MSE to compare your models. But good models, right? In most cases, will have lower MAD, lower MSE, and lower MAP than your competing models, right? Most of the times, more data is better. Not always the case, right? Not always the case. Most of the time, more data is better. MAP, but again, remember there's a loss of information. If you are sure you want to use MA20, you can't make a prediction using MA20 at the 11th period because you don't have 20 data points, right? So it's a delicate balance. But the idea is, how do you choose between two models? Is MAD, MSE, and MAP. What they are really looking at is this notion of a pudding can be judged by its test, right? How do you know it's a good pudding? Is put it to eat it, right? Put it to the jury of foodies, right? So if you make a prediction of 55.58, how do you know it's a good model? Is compare it what you would have seen otherwise. So this is the idea behind this kind of models.